and gentlemen, welcome to Regional Speak Out for Engineering Presentation Competition for the Southeast Asia and Oceania 2007. I'm Eunice Chen. Our competitors today will give an oral presentation on a subject related to mechanical engineering.
And the topic of my presentation today is about the computational fluid dynamics in centrifugal pump design. This is a cross-sectional view of the centrifugal pump, okay? If you look at this diagram here, alright, there's a lot of components. As I say, right, the water will go into the pump in an axial direction, okay? And this thing is rotating, right? So we discharge the water, and the water will coming out from here. Right? Show you what we call it streamline board. It means to show how the water flowing into the pump. Then next thing is the pressure distribution of the pump. This one is important for the bearing design, okay? Because uneven pressure distribution will cause a lot of vibration problem.
But have you thought about that? What will happen if there is a fire when you're traveling in the underground mass transit where provide a safety environment for the passenger? The answer is a good ECS design. What is the meaning of congested case in the tunnel? It means due to the delay or operation problem, the train will stop in the tunnel or in the station and affect the schedule of the train. And this application will be used when the ambient temperature is cold, so that the station, trackway and tunnel area is cooled by the outside air. Of course, the people comfort depends on the temperature, humidity and the air movement. And there is air movement in the station when we are using the combined closed and open system. In case of fire, the life of the passengers is in danger. So we need to turn on the tunnel ventilation fan to provide an airflow so that it can use it to control the smoke, and it can provide a smoke-free evacuation path for the passenger.
He broke the first two vertebrae of his neck. Subsequently, he was paralyzed waist down and he passed away in 2004. Basic skeleton body. And the spinal cord itself is located in the backbone here, indicated in red. Now, there are three main layers. The first one called the pia mater, the second one called the subarachnoid mater, and the outermost called the dura mater. For spinal cord injury, 50% of all spinal cord injury are due to motor vehicle accidents. The basic experiment setup, this is a tough knob, which is going to simulate the bone fragment. One of the problems was that we actually find that there is a distance in between the spinal cord and the element that we wish to experiment with in the spinal cord during spinal cord injury. Moreover, I have also proven that the shape and confines exploded. In a way, if you were to smash something, you actually see all the bits flying around. That was what happened with Christopher Reeve.
I found your presentation very interesting. It would never have occurred to me before that a mechanical engineer could contribute to the spinal cord. I mean, to me, this is a medical issue, not a mechanical issue. So
we want to continuously test the thing and make sure that the material that we are using is going to be as close as possible to the real thing. But they do not know how is that going to work. They do not know what is pressure, they do not know what is velocity. Okay, maybe I'm pushing it at velocity, but they do not know what is anisotropic. They do not know that what is megapascals for elastic modules, what is this. They basically have no idea in that. So that's where biomechanical engineering actually comes in.
For the system that we've developed, we used an off-the-shelf digital SLR, in this case a Canon 20D, which has an 8.2 megapixel sensor images, we cannot compare what happens between the two images to get an overall idea what is happening. This is quite similar to what we had previously with the CFD. In our case, doing research in mechanical engineering, we're using something called PIV, particle image velocimetry, which is a camera which can take two very quick images behind each other and then uses statistics to actually analyze a fluid dynamics flow, to be able to directly cut down the time you will need for experiments, because we've gone and taken these PIV measurements, and this is exactly the same flow.
Standard was excellent of all four, without doubt. Kiwi Chia from Singapore. The positives for you was your structure. It was very clear, very precise structure. You set out what you wanted to do and you achieved that through your presentation. Alice from Hong Kong. The positive was your style. You came up here and you made an impact straight away. And the introduction itself was very good. And also, with Ian's questioning, we thought you handled that very well. And also, Soon Yu Wong, that's pronounced correctly, from Malaysia. You think your positives was your speaking style. The fact that you came out and talked to the audience and didn't hand behind the desk in that sense. Second prize, I need a drum roll. And it goes to Michael Rees from the Australia branch. From Malaysia.
This very first South Asia and Oceania. That was an interesting word. Oceania was a description. Yeah. Speak Out for Engineering Presentation Competition. It was a privilege to be here, and it was a privilege to experience the presentations. I thought they were absolutely excellent. Congratulations to all of you. You all can win, but you all can participate and demonstrate to us how good you are at understanding your subject and communicating.
Okay. 1, 2, 3, cheers. One more. 1, 2, 3, cheers.